Okay, welcome again. Today's lesson we'll be talking about the cosine rule or laws of sine. The last lesson we spoke about the sine rule. So today we're going to focus on the cosine rule. Okay, let's get into it. So remember that we say that the cosine and the sine formula are used to find sides and angles of triangles that are not right angle triangles. Now, oftentimes in a related text, you might see these two formulas, and most times you don't think it's two different formulas. It's the same formula, but when they were deriving the formula, the side of reference, they used to came out with this formula. But as I play around with some triangles, you'll understand. Okay, so the most often one time students use is b square is equal to a square plus c square minus 2ac cos b cosine formula. So observe, common letter, common letter, common letter, common letter, common letter. So these common letter represent the side of a triangle that the question will be focusing on. And if you observe, whatever side comes after the equal sign in the formula, these two sides is always multiplied by a 2. A and C is repeated here. And the side that is started with b square, we always find the angle, cos the angle that is opposite to it. So if it had started with C here, then we have cos C here. If it had started with A here, then we have cos A here. So observe, side that we start with, find the angle opposite to it. Whatever side that is repeated here, that is added here, is multiplied by the 2 here. Okay? So again, we say it's not two different formula. You just rewriting the formula. If I start with side C, I find cos of C at the end. Then if I start with C, the triangle is labeled ABC, then A and B would fall here. And since A and B is added here, then we multiply it by 2. Okay? Alright, let's play around with some triangles to understand the formula a little bit more. Let's say we have triangle ABC here, and we want to find sine C. I want to create the cosine formula using this triangle. See, I'm going to label the triangle in this direction, angle A, B, C. Then, like the sine rule, we're saying that the side that's opposite to the angle we'll call this common A. Sides opposite to this angle C, we call this common C. On the side that is opposite to angle B, we call it common B. And if we want to create the formula, if they say find side C, the side of reference, then we start with C. So the formula would say C square, common letter, equal, because the formula is in the equal after you start with the angle of the side of reference, sorry. Then if we start with C, which other two sides is left? A and B. It doesn't matter which one you put first. So we'd have A square plus B square minus 2 multiplied by two sides that's here, which is A, B. Then we'll cos what we start with, the side is C, then we're going to cos angle C. So that's how we come up with the formula. So the formula can be changed based on the side of reference. And remember, triangles will not always be labeled ABC. It can be EFG, PQR, XYZ. Okay, let's try another one to understand the formula a little bit more. Okay, so the standard formula in my senior's textbook is b square equal to a square plus c square minus 2ac cos b. Okay, now let's suppose I should label this triangle now. Another triangle ABC, another direction. The first one I label it in this direction. Suppose I should say A, B this side, and C. Then the side opposite this angle would be side A. And the side opposite this angle, angle B, would be common B. And the side opposite this angle C would be common C. But suppose I should create the formula if they say find side B. Then I start with side B, will be B square, equal. Then if I start with B, which are the two sides left? A and C. So we'd have A square plus C square minus 2. 2 should be multiplied by whatever side is here, AC. Then we're going to cos what? The side that we started is side B, so it's the angle opposite, which will be angle B, and that's how we create the formula. So the first triangle we label with ABC, this direction, this one we label it, so is the angle of reference. And point to note, if you're observing this part of the formula, look like the Pythagoras theorem. Okay, let's play around it one more. Let's say this triangle is called EFG. So angle E, angle F, angle G, capital letters. Then the side that's opposite this angle, we call it common E. The side that's opposite this angle, we call it common F. And the side that's opposite this angle, we call it common G. So remember, we can label side with 2 capital letters or 1 common letters. Okay? But they say find side E. That means that you're going to create the formula based on the reference of side E. So what we start with? E square is equal to, if I start with side E, which two other sides remain? F and G. So F square plus G square, common letters, minus 2 multiplied by what? Whatever side is there, FG. Then we'll cos, what did we start with? E. Then we'll have capital E, and that's how the formula is created. Okay, so it's not something you have to swat. What you start with, you cos the angle of it. The remaining side comes here and you multiply it by the 2 times. Alright, let's go to an example. Let's see when we use the cosine rule, like how when we use the sine rule. Alright, but the key thing is that it's for triangles that are not right angles. Alright, first condition when we use the cosine rule. When given the length of 2 sides and an angle between both sides. So when given the length of this side RQ, to find when we're given the length of 2 sides, we can see that the angle is between the 2 sides. Then this is one criteria, one condition when we use the cosine rule. Again, when given the length of 2 sides and an angle between the 2 sides. Now in this question is asked to find x. And sometimes when I give the question like that, it confuses students. But don't be confused. If they give you x, you can remove the x and use what you are used to. This is angle Q. What side is opposite to it? Common Q. Angle T. What side is opposite to it? Common T. Angle R. What side is opposite to it? Common R. But they said to find x, and x was here, right at side Q. So the angle or the side of reference is Q. So we start with Q square. So this is what I'm saying, that the formula does not have to be b square equal a square plus c square minus 2ac cos b. Is based on the angles or the side or the letters that the triangles are named with. Alright, so because it asks for x and x is where q is, equal. So if I start with q, which other 2 sides are left? T and r. So we'll have t square plus r square minus 2 multiplied by what? The 2 sides that are here, t and r, and then we'll cos angle q. Okay, so don't think that the formula will be the same because it's based on what the triangle is named with. Okay, so remember that q is x. Okay, so q square is equal to t square. What is t? T is 11 square plus r. What is r? R is 9 side r, 9 squared minus 2 times t times r cos. What's the angle of cos q? Angle q is 71 degrees. Okay, now q squared is equal to 11 square, which is 121, plus 9 square, which is 81, minus, if we multiply all of this, we find cos 71, and then we multiply all of this here. I think we'll end up with 64.46. All right, so q square is equal to 202 minus 64.46. Therefore, remember that q is x, and x they asked us to find. We can transform back q now back into x. So x squared is equal to 202 minus 64.46 will give us 137.54. So to solve for x now, x is squared. So in order to substitute and remove the square, then we square root both sides. And if we square root both sides, we end up with x, and we square root this side, 137.54. And the square root of that will give us, x will therefore be equal to 11.73 meters. So this is one condition. When you are given two sides and an angle between, we use the cosine rule. Condition 2. Let's look at condition 2 when we use the cosine rule. When given all three sides to find an angle. So if you observe this example, we're given three sides, triangle ABC. The sides are given, but we are asked to find angle x here, and angle x is the same as B, so don't let the question confuse you. Okay, so we can still label this side as A, this side as B, and this side as C. It's easier to work with the sides, and don't ignore the x until you reach to the final stage. We change back to what the question is asking for. So the question is focused on finding x, which is at angle B. So the angular side of reference is B. So we started with B. So therefore, B squared equal, and if we start with B, which other two sides left? C squared plus A squared minus 2 was multiplied by what? The two sides that are here, C and A, and then we cos what we start with, side B, then we cos angle B. Now we substitute the variables now for the constants, the numbers. So B here is 40 squared equal, what is C? C is 34 kilometers square plus, what is A? 26 square minus 2. What is the 2 multiplied by? C and A, whatever is here, so it's 34 times 26 cos B, which is cos, what is angle B? Don't know, so we call it X, because we started with B, so we wanted to find B, but B, we don't know the angle. Because this second condition, we have three sides and find an angle. Okay, so doing our calculations, a 40 squared would work out to be 1600 equal 34 squared would work out to be 1156. 26 square would work out to be 676 minus 2 times 34 times 36 would work out to be 1768 cos x, because angle x we're trying to find. Now this calculation will work out to be 1600 equal, when you have this, we get 1832 minus 1768 cos x. Now sometimes student makes an error here. So this looks like algebra. This will represent, for example, 2x and a constant. We cannot subtract, and we're trying to find angle x. So what I'm going to do, I'm going to transpose and get the x on one side by itself. And since it's negative, because sometimes we don't realize that this is like 2x. So I'm going to transpose and bring it to the left, and transpose the 1600 and bring it to the right. So this negative, let's pretend it's like 2x is there. So we're transpose, when it comes over, it'll be positive 16/8 cos x. Because the aim of algebra is to get the variable on one side by itself. The 1800 was not, and 32 was not transposed, so it remained on the right. Then we transpose the 1600, and that's how the equation is rewritten. Okay, so when we carry out this calculation or computation here, we'll end up with 234, and we're going to transpose back this 1768, leaving the cos x and dividing by 1768. So this 234 divided by 17, the result will give us 0.1323 and so on. However, we haven't found x as yet. We haven't found angle x. This is cos x. We haven't found x. So remember, when time the trig ratio is beside the variable, we have to transpose and it becomes the inverse. So therefore, when we transpose cos x, it's going to become the inverse. Okay, so x would be inverse, cos inverse, when we transpose, of 0.1323 and some remaining digits. And when you transpose that and you find the inverse, you're supposed to get 82 degrees. Now sometimes you make errors with this part right here, so please remember, we're trying to find x, so we transpose and get the variable by itself. But when time we transpose the constant, the coefficient of cos x here, remember we still haven't found x, it's cos x, so we have to transpose the cos from beside the x, and we get the cos inverse. So when we divide, we get this figure, and the inverse of this gives us the 82 degrees.